Hello everyone, let's see this question. Particle A moves with constant speed 2 meter per second on a circular path of radius 4 meter, whereas particle B moves along a straight line through the center of the circular path, always maintaining a constant distance 4 meter from particle A. Then which of the following conclusions can be drawn? Let's try to imagine this, how it would look. So we are having this circular path, and on this particle A is moving with a given speed, let's say this way right now, and particle B moves in a straight line through the center of the circular path. Okay, so I can take a straight line like this through the center of the circular path. Now as A moves, B also will move because it has to maintain constant distance from A, right? And that constant distance is given to us as 4 meter. So this moves at a constant distance of 4 meter. Okay, somewhere here maybe. This is B. Okay. Now, which of the following conclusions can be drawn? So let's see. Let's imagine this to be V, and this distance is supposed to remain constant. Let's say this angle is theta. So from there we know that this angle will also be theta, and this will be 90 minus theta. Okay, so V is along that line. Now B is moving this way on the straight line. Okay, let's say velocity of B, I am taking it as u. Okay, now what should happen? The velocities, they should be same along the line joining them, because separation does not change. So it is given to us that the radius is 4 meter, and the distance that it maintains is also 4 meter. So these two lengths are same in the triangle. So since these two lengths are same, we can say that this angle will also be theta, because it will be an isosceles triangle. Okay, so here what will happen? The velocities, what will be the line along which they are acting? I'll just show it with a different color. So V is going along the tangent, right? V is along the tangent here. Now what angle will this make with this line? So the other line along which the particle B is moving, okay, particle B is moving along the horizontal line, but its velocity towards A will be this direction, right? Now how much angle does this direction make? So we know this total angle will be 90 degree, right? And we know that this angle is theta, this angle is also theta. So that means what? That means this entire angle from here till here, this entire angle will be 2 theta. Hence this angle will be what? This angle will be 90 minus 2 theta. Okay, and now just take a moment, pause the video if required, and just understand the angles. Okay, now what? Now velocity of approach and separation we can write. So u cos theta is the velocity with which it is approaching A, and this should be same as the velocity with which A is running away, and that is V cos of 90 minus 2 theta. So that gives us V sine 2 theta. So what do we get from here? We get that u is equal to 2V sine theta cos theta by cos theta, which is just 2V sine theta. Now V we know is how much? 2 meter per second, right? So that's why this becomes 4 sine theta. So is the first option correct? A, yes, maximum speed of B is 4 meter per second, because maximum value of this is 4. Then maximum acceleration of B. So maximum acceleration of B, how to find? You can just differentiate this. So if you differentiate the velocity, you'll get acceleration. So you'll have what? You'll have 4 cos theta into omega. Now how much is omega? Omega is a constant. Omega is V by R. So So you'll have 4 into V, which is 2, divided by R, which is 4. So you get what? 2 cos theta, which again has a maximum value 2. So that's also correct. Then it's written, during one revolution of A, distance traveled by B is 32 meters. So let's understand this. When A was here, B would have been 4 meters behind, right? Now when A comes over here, then B would be at the center because the radius is 4 meters. And now what will happen after this? B has to move even more forward because suddenly B cannot change its velocity, no? When it is coming here and when it is at the center, it is having a velocity this way. So if the velocity changes continuously and not discontinuously, then in that case it has to go forward only. So as it goes forward, when A is here, then B will be here. So that means what? B starts from 4 meter back from here. 4 meter back from here. Then this distance is what? 8 meter, right? And then when A is here, then B is 4 meter here, right? So this is just in half revolution. In half revolution, B has traveled 16 meter forward. Same thing will just go reverse when A completes the lower half of the revolution. So what would you get? You would get, during one revolution of A, distance traveled by B is 32 meter. That's also correct. Then option D, modulus of velocity of a particle relative to the other is a constant. So this also we'll have to write. So see, U is just along x-axis, so you can just write it as ui cap. Okay, so velocity of B is simply ui cap, but velocity of A, that changes the angle, right? So at any general instant, V, how much angle it is making with the horizontal. So we know that this angle is theta, so this is also theta, so this will be 90 minus theta. So VA will be how much? It will be V sin theta I cap plus V cos theta j cap. And now when you calculate the relative velocity, okay, let's say I'm doing VAB, VA minus VB, then how much will it be? It will be V minus V sin theta minus U, V sin theta minus U I cap plus V cos theta j cap. Now U is how much? U is 4 sin theta. Basically, V value is how much? 2. So substitute all those things. So what you will get? You will get 2V sin theta minus, so V sin theta minus, here you will have 2V sin theta. U is what? 2V sin theta I cap plus V cos theta j cap. So what do you get? You get minus V sin theta I cap plus V cos theta j cap, which indeed has a constant magnitude, right? What is the magnitude? It is this square plus this square root over, which gives us what? V. So option D is also correct. All the options are correct.